Hello everyone, do you know about lipid metabolism? So in this opportunity, we would like to present about lipid metabolism. So let's start right now. First of all, we would like to say thank you to Mr. Ahmad Farurozi as our lecturer. And now I will introduce the names of our group. First, there is Lutfia Astrid as the reader of slide 5 to 8. Second one is Jill Fiona as the reader of slide 9 to 11. The third one is Diva Zara as the reader of slide 19 to 22. And the last one, but not least, there is Merfiana Arahman as the reader of slide 12 to 18 and 23 to 28. In this presentation, you will get about 1. Definition of lipid, 2. Types of lipid source, 3. Function of lipid, 4. Lipid digestion process, 5. Lipid metabolism process in the body, 6. Lipid acid oxidation in the body, 7. How to calculate lipids. So let's start to our presentation.
Definition of lipid. Lipids or fats are defined as heterogeneous organic compounds that occur in nature and are relatively insoluble in water but soluble in nonpolar solvents. Lipids are compounds containing a carbon and hydrogen which are insoluble in water but dissolved in an organic solvent. Fat is substance that is rich in energy, serving as the main source of the energy for the body's metabolic processes. Fat circulating in the body is obtained from the two sources, namely from food and the production of the liver, which can be stored in fat cells as energy reserves. Types and source of lipid. Based on its chemical composition, fat can be divided into 3, namely simple fat, mixed fat, and real fat. Based on its chemical bonds, fat is divided into saturated fat and unsaturated fat. Meanwhile, based on the source, fat is divided into 2, namely vegetable fat and animal fat. Here are various types of foods that contains natural sources of fat. Example source of vegetable fats. First, avocado fruit. Avocados are rich in monounsaturated fat, and this medium-sized fruit can contain 22 grams of fat. These fruits also provide 20 important health benefits, including boosting nutrients including fiber, potassium, vitamin E and B, and folic acids. In addition, avocado still has many other benefits, namely anti-inflammatory properties, increasing the absorption of fat-soluble nutrients such as beta-carotene and lutein, then increasing the lipid content of fat, as well as inhibiting and destroying oral cancer cells. Second, walnuts. Walnuts only provide pleasure when consumed, but are also a rich source of nutrients in monounsaturated fats. This type of food has been recommended for those with cardiovascular problems and has anti-cancer properties, anti-inflammatory effect, and brain health properties. To get the benefits of walnuts, you can eat them in salads or in vegetable and fruit dishes. And then, from the animal fats, there are 2 examples. First, fish oil. Many of the benefits of fish oil are due to the presence of essential omega-3 fatty acids, such as DHA and EPA. The essential fatty acids that are useful in fish oil are alpha-linolenic acids and gamma-linolenic acids. According to the American Heart Association, omega-3 are effective in reducing the incidence of the cardiovascular disease. This is one reason commercial oils have been linked to a reduced risk of heart disease. Second, sea fish. Sometimes Some types of fish contain fat which is very good for health. Salmon, sardines, herring, mackerel, and tuna are types of fish that contain omega-3 fatty acids. Fat in fish needed to help growth, development of brain function, and reduce the risk of the cardiovascular disease.
Function of lipid. First, serve as energy source as well as storage for energy. 2. Insulating the body from environmental temperature change and preserving body heat. 3. Structural component of cell membrane. 4. As a protector of important organ from mechanical trauma. 5. As a solvent A, D, I, K vitamin. Lipid digestion process. As stomach contains enter the small intestine, it stimulates cholecystokinin hormone. Cholecystokinin hormone causing gallbladder contraction and produce gallbladder fluid. Gallbladder fluid is an emulsifier enzyme. With help from enzyme pancreatic lipase, fat emulsion being hydrolyzed become fatty acid and glycerol. Both fatty acid and glycerol will react with bile salts to produce micelles which are ready to be absorbed by the empty intestine and absorption intestine. By passive diffusion, the micelle will be absorbed by the mucous membrane in the empty intestinal wall and absorption. These micelles are carried and channeled through the bloodstream throughout the body. So, on the left picture, we can see that fatty acid and glycerol react with bile salt to produce micelles which are ready to be absorbed. Then micelles will be absorbed by mucous membrane. After that, these micelles are carried and channeled through the bloodstream throughout the body. Then, on the right picture, digestion of fat starts from the oral cavity, then enter the esophagus and stomach, then into the intestine. The intestine is the actual digestion of fat from the small intestine to the large intestine and then anus.
Lipid metabolism process in the body. Fats or triglycerides within the body are ingested as food or synthesized by adipocytes or hepatocytes from carbohydrate precursor. Lipid metabolism entails the oxidation of fatty acids to either generate energy or synthesize new lipids from smaller constituent molecules. Lipid metabolism is associated with carbohydrate metabolism, as products of glucose, such as acetyl-CoA, can be converted into lipids. There are 5 lipid metabolic pathways. First is lipolysis, or triglyceride breakdown. Lipolysis is the cleavage of triglyceride to glycerol and fatty acid. There are 2 primary lipolysis enzymes. The first one is lipoprotein lipase, or LPL, and the second one is hormone-sensitive lipase, or HSL. In the fat state, LPL on the endothelium of blood vessels cleaves lipoprotein triglycerides into fatty acids so that they can be taken up into adipocytes for storage as triglycerides or myocytes, where they are primarily used for energy production. HSL is an important enzyme in adipose tissue, which is a major storage site of triglyceride in the body. HSL activity is increased by glucagon and epinephrine and decreased by insulin. Thus, in hypoglycemia or a fight or flight response, triglycerides in the adipose are cleaved, releasing fatty acid into circulation that then bind with the transport protein albumin. Thus, HSL is important for mobilizing fatty acids so they can be used for produce energy. The second step is de novo lipogenesis, or fatty acid synthesis. De novo lipogenesis is the synthesis of fatty acid beginning with acetyl-CoA. Acetyl-CoA has the first move out of the mitochondria, where it is then converted to malonyl-CoA, 3 carbons. Malonyl-CoA then is combined with another acetyl-CoA to form a 4-carbon fatty acid. 1 carbon is given off as carbon dioxide. The addition of 2 carbons is repeated through a similar process 7 times to produce a 16-carbon fatty acid. The third step is a ketone body synthesis. In cases where there is not enough glucose available for the brain, very low carbohydrate diets, starvation, the liver can use acetyl-CoA, primarily from fatty acids, but also certain amino acids to synthesize ketone bodies or ketogenesis. The structure of the three ketone bodies is acetone, acetoacetic acid, and beta-hydroxybutyric acid. After they are synthesized in the liver, ketone bodies are released into circulation where they can travel to the brain. The brain converts the ketone bodies to acetyl-CoA that can then enter the citric acid cycle for ATP production as shown below. The last step is a cholesterol synthesis. Acetyl-CoA is also used to synthesize cholesterol. As shown below, there are a large number of reactions and enzymes involved in cholesterol synthesis.
Next is lipid acid oxidation in the body. Fatty acid oxidation or beta oxidation. To generate energy from fatty acids, they must be oxidized. This process occurs in the mitochondria, but long-chain fatty acids cannot diffuse across the mitochondrial membrane, or similar to absorption into the enterocyte. Carnitine and amino acid derived compound help shuttle long-chain fatty acids in the mitochondria. And then is fatty acid shuttling. As shown below, there are two enzymes involved in this process. Carnitine palmitoyltransferase 1 or CPT1 and carnitine palmitoyltransferase 2 or CPT2. CPT1 is located on the outer mitochondrial membrane. CPT2 is located on the inner mitochondrial membrane. The fatty acid is first activated by adding CoA or forming acyl-CoA. Then CPT1 adds carnitine. Acyl-carnitine is then transported into the mitochondrial matrix with the assistance of the enzyme translocase. In the matrix, CPT2 removes carnitine from the activated fatty acids. Carnitine is recycled back into the cytosol to be used again. And then is fatty acid activation. As shown below, the first step of fatty acid oxidation is activation. A CoA molecule is added to the fatty acid to produce acyl-CoA, converting ATP to AMP or adenosine monophosphate. Thus, activation uses the equivalent of two ATP molecules since it typically cleaves to ADP. Next is fatty acid oxidation. Fatty acid oxidation or beta oxidation because two carbon units are cleaved off at the beta carbon position of an activated fatty acid. The cleaved to carbon unit forms acetyl-CoA and produces an activated fatty acid or acyl-CoA with two fewer carbons, acetyl-CoA, NADH, and FADH2. To completely oxidize the 18 carbon fatty acid above, 8 cycles of beta oxidation have to occur. This might seem like 1 to 5 cycles, or 18 divided by 2 is 9, but the last cycle will split the 4 carbon fatty acid into 2 acetyl-CoAs, meaning that it only takes 8 cycles to completely cleave the fatty acid.
Now I will explain you how to calculate lipid. Although the terms overweight and obese are often used interchangeably and considered as gradation of the same thing, they denote different things. Overweight refers to having more weight than normal for a particular height, and may be the result of water weight, muscle weight, or fat mass. Obese refers specifically to having excess body fat. In most cases, people who are overweight also have excessive body fat, and therefore body weight is an indicator of obesity in much of the population. The perception of the ideal body weight is additionally dependent on cultural factors and the mainstream societal advertisement of beauty. To standardize the ideal body weight and relate it to health, scientists have devised mathematical formulas to better define a healthy weight. Body mass index or BMI is calculated using height and weight measurement and is more predictive of body fatness than weight alone. BMI measurements are used to indicate whether an individual may be underweight with a BMI less than 18.5, overweight with a BMI over 25, or obese with a BMI over 30. High BMI measurement can be warning sign of health hazard ahead, such as cardiovascular disease, type 2 diabetes, and other chronic disease. How to calculating BMI? BMI equals weight in Libra times 703 divided height inches to BMI equals weight in kilogram divided height in meters to BMI limitation and measuring body fat content. A BMI is fairly simple measurement and doesn't take into account fat mass or fat distribution in the body, both of which are additionally predictors of disease risk. Body fat weight less than muscle mass. Thus, a muscular athlete will be less ideal and can be categorized as overweight based on BMI. The optimal fat content of a female is between 20 and 30% of her total weight, and for a male is between 12 and 20%. Therefore, we need other measurements to diagnose obesity and assess disease risks for more accurately. The skin fold test. The skin fold test is the simplest and the lowest cost way. A health professional uses a caliper to measure the thickness of skin on the back, arm, and other parts of the body and compares it to standards to assess body fatness. It is non-invasive and fairly accurate method of measuring fat mass, but similar to BMI. The second one is underwater weighting. This technique requires a chamber full of water big enough for the whole body to fit in. First, a person is weighed outside the chamber and then weighed again while immersed in water mass. The third one is bioelectric impedance analysis, or BIA. This device is based on the fact that fat slows down the passage of electricity through the body. When a small amount of electricity is passed through the body, the rate at which it travels is used to determine body composition. These devices are also sold for home use and commonly called body composition scales. The last one is dual energy X-ray absorptiometry, or DEXA. This can be used to measure bone density. It also can determine fat content via the same method, which directs to low-dose X-ray beams through the body and determines the amount of the energy absorbed from the beams. The amount of energy absorbed is dependent on the body's content of bone, lean tissue mass, and fat mass. Using standard mathematical formulas, fat content can be accurately estimated. Measuring fat distribution. Fat can be found in different areas in the body and it doesn't all act the same, meaning it differs physiologically. Measuring fat distribution. Fat can be found in different areas in the body and it doesn't all act the same, meaning it differs physiologically based on the location. Fat deposit in the abdominal cavity is called visceral fat, and it is a better predictor of disease risk than total fat mass. The only tool required for measuring visceral fat is a measuring tape. The measurement of waist circumference is taken just above the belly button. Men with a waist circumference greater than 40 inches and women with a waist circumference greater than 35 inches are predicted to face greater health risks. To calculate your waist to hip ratio, use a measuring tape to measure your waist circumference and then measure your hip circumference as its widest part. Next, divide the waist circumference by the hip circumference to arrive at the waist to hip ratio. Observational studies have demonstrated that people with apple-shaped bodies, who carry more weight around the waist, have greater risk for chronic disease than those with pear-shaped bodies, who carry more weight around the hips.
So this is reference that we use in this video. Thank you for watching. If you have any question, please write down the question in the comment section. See you.